I'll say a couple of brief things about me that are going to be important because not everybody from here knows a lot about where I'm from. I am from Texas, Houston, Texas, to be specific. And there are some things that you should know. Number one, I live in a city, not on a ranch. Number two, I drive a car. I don't ride a horse. And number three, unfortunately, I don't own an oil well. And probably the most important thing about me is that I really am James Bond's brother. My grandfather, my father, my brother, and a nephew were all named James Bond, and at my age, we had the name before Ian Fleming did. I'm always happy to come and participate in groups like this, where people that have common interests but different experiences can come together and talk with each other about how to improve something that's important. And that's especially true in a case like this, where what we're talking about is flour milling, an industry that has provided a living for many of us. And much more importantly, it provides one of the basic food groups for billions of people throughout the world. And so it's important that we do this. Now, when I was first approached to make this presentation, it said that they wanted me to talk about flour milling in Latin America from a miller's viewpoint. And I told them that I couldn't do that because I'm not a miller. I have never operated a mill in my life. What I have been is I have been an engineer that has participated in the design of flour mills at several places around the world. And I have been responsible for groups that have designed. And so what I agreed to do is that I would talk about flour milling in Latin America from a milling engineer's point of view. And those two things are a little bit different. If I were to talk about flour milling from a milling engineer standpoint and concentrate on flour milling in Latin America, I guess my first comment would be that I have no reason to expect or to believe that flour milling in Latin America is terribly different from flour milling in the United States or in Europe, for that matter, where a lot of the technology that's being employed originated and came from. The process is being used in Latin America, in my opinion, it's proven, it's reliable, it is reasonably efficient, but with a couple of exceptions that we'll get into later. The process is really the same process that's been used in flour milling since 1860, when the concept of the purifier came into play. To be sure that I was prepared for this, I wanted to answer the question, what do people expect a milling engineer to say? And I think that my experience has been that when an engineer is asked to talk about anything in an industry, what they really want to hear is they want him to tell them what's new in the industry or what's really innovative or what has changed. And if I were to do that, I wanted to be prepared, so I enlisted the help of Google's artificial intelligence application. I asked this simple question: what are the most important advances in the technology of flour milling in the last 50 years? And this slide was the result. You can see that they mentioned many things, among them automation, digitalization, IT integration, enhanced quality control, hygienic design, pneumatic conveying. All of these things are important, but with the exception of two items on this list. These two items are the application of electronic sorting in the cleaning house, and the other was the application of debranding techniques prior to reduction. These two are the only ones in this whole list that made any basic changes to the process of flour milling. All of the rest of them had to do with how we control it, how we measure it, how we automate it, or how we evaluate it. Only two in the last 50 years have really tried or attempted to change the basic flour milling process. And it's interesting because both of these just barely made the deadline. To the best of my knowledge, the concept of introducing optical sorting in the wheat cleaning houses was first suggested at an Association of Operative Millers convention in Toronto in 1983 in a presentation that was talking about crossover technologies that should be applicable for both wheat milling and flour milling. 1983. So it's made that 50 years, but not by much. The other is the debranding technology, and that concept came about in the latter half of the 1980s, when at the same time, a gentleman named Joseph Tack and his sponsor, Reg Tim, from Tim and Sons Milling in Goole, England, were trying to develop a process to use debranding prior to milling as a way of producing a higher yield of low ash flour. The same process was being developed at the same time independently by Satake Corporation from Hiroshima, Japan. And those patents were filed around 1987. So you can see it's been almost 40 years since that was introduced. So if I were to honestly speak of what's happened in flour milling in the last 50 years, what's changed? This would be a very short presentation, and my answer would have to be not much. Now, we might ask ourselves, though, why is this the case? Why hasn't the flour milling process changed? Other industries have changed. Why is this one so resistant to change? And so the first thing that we should do is give credit to a process that has proved to be very reliable, very efficient, and has been economically viable. Although this is where we're going to later on discuss where we might need to make some changes. But it hasn't changed much, and we are still milling the same way that people were milling basically. This slide depicts a section view of a mill in 1905. What would you recognize? You'd recognize cleaning, you'd recognize roller mills, you'd recognize sifting, you'd recognize purifiers, and this is still the same basic process that we're using today. So the process is a good one. And so, although we're going to have to be critical about it and look at it with a critical eye, we have to recognize that this is a very good process indeed. A second reason, though, why a process is resistant to change is because as you do make changes in the process and you get closer and closer to what the goal is, the maximum theoretical efficiency, it becomes more and more difficult to be able to make changes that make economic sense. And so this is also a case that's applicable to the flour milling industry. And then the final one is that when we try to optimize a system and we fail, then we might just simply tend to say the process is as good as it can get, and we quit trying. And I think all three of these statements, while they have some validity, have been applicable to the flour milling industry, at least the flour milling industry in the Western world. And together, they violate what I think ought to be the first law of flour milling. I think the first law of flour milling ought to be this. Flour milling is fundamentally about neither flour nor milling. It's about money. Now, that sounds easy enough for all of us to agree to. When I asked Google's artificial intelligence application to give me an illustration for this is what I got. And it gave me this illustration. It also gave me a comment, and the comment was, that's a very interesting and cynical comment. Well, everyone knows that old men and computers don't get along very well, and so I'm 78 years old, and I'm going to respectfully disagree with Gemini artificial intelligence. I don't believe it is cynical at all to say that everything about flour milling, from the wheat we buy, to the machines that we use, to the processes that we control, and to the instruments that we control, all of those are not the important thing itself. They are means to an end. And the goal of flour milling should not be to make any specific yield or to make any specific standard, product standard, like ash content, falling number. The goal of flour milling should be to create the maximum value that can be gained by selling wheat and each of its byproducts. And until we can answer and say that we have done that, then the process will never be optimized. And if we think of it in terms of technical processes, instead of the fact that our flour mills should be economic engines, then we will never, in my opinion, truly optimize the process. And that brings me finally to South America, because I am aware of something that's been going on in South America that is a little bit different. And there have been 3 companies which I refer to as hidden gems, like finding diamonds hidden among rocks. They're there, they're valuable, but people don't notice them. In this case, it represents 3 companies, all of which have been around, all of which have been working in the cereal processing industry, all of which have been making contributions, but may not have been the most recognized names in the industry. These 3 companies were Molino Tres Castillos, which is a flour mill that is operating out of Cartagena, Colombia; Superbricks, a company that manufactures grain processing equipment and designs plants, and they're located just about 60 miles up the coast from Cartagena in Barranquilla. And the third was Applied Milling Systems, which is a milling engineering and plant design company that's operating out of Houston, Texas. And all 3 of these were working together, and what they were trying to do was they were trying to use the concept of debranning before reduction in a flour mill, seeing if they could get a higher yield of low ash flour. And like their predecessors, TAC and TIM and Satake, they were having very limited results. But what happened next wasn't typical. Instead of giving up and saying that the process is as good as it can be, they got together and they asked the single most important question in optimizing any process. And that question is, well, what if? And in this case, what they decided to do was to do something radical. And instead of putting wheat in the inside of a milling chamber, of a debranding machine, they said, what happens if we put bran in there? what would happen? What would we get out? Would we be able to purify the bran any better? And when they did, they found something that was quite unique, quite surprising, and had very huge implications as far as for optimizing the economic engine that I've been talking about. What happened was they found that when they put bran in the milling chamber instead of wheat, that what they got out of the milling chamber was a very, very colorless product that was extremely high in alburon. And that then caused each of them to be thinking about the process in their own ways. The milling company thought, well, what if I can make a product that looks like white bread flour and bakes like white bread flour, but it has the nutritional characteristics of whole wheat flour? And the manufacturing company said, well, what if we can find a new application for the machine that instead of trying to debran wheat, it purifies the bran that wheat mills already produce? And the milling engineer said, well, what if we could find a way that we could produce the same yields of low ash flour, but we could produce it in a much shorter flow, in a much shorter process? And so then what happened is they decided to make some modifications. And instead of putting bran in a milling chamber that was designed for wheat, they put that bran in a milling chamber that was specifically designed to extract high alburon flour from bran and made it into a more efficient bran purifier. Why is this important? Because that alburon layer makes up fully 7 to 9% of the weight of the grain, and it contains almost all of the nutritional value of the wheat. It is colorless, and if it is taken off in the right manner so that the particle sizes are small enough, it has no detrimental effects on the baking process. And so they developed a machine that was specifically designed to be able to extract alburon-rich flour from the bran that mills traditionally made. How did they do that? They basically put bran in a chamber, if I can, my pointer's not working. But if you can see where the yellow arrow is, they would put bran in the annulus of a milling chamber where it's exposed. What's this one? Okay. Oh, see what I said about old men and computers and technical things? But if you put bran in a chamber that has alternating segments of emery or abrasive materials, and then in addition, you use an eccentric rotor, and what happens is you create cycles of high and low pressure, which causes whatever particles are in that chamber to move relative to each other. And it causes cycles of compression and relaxation, which gives a very, very efficient rubbing action. And in addition, the abrasive segments that are in there scratch the grain or scratch the bran that's in there and remove the fine particles of alburon that are on there. And then the alburon rich flour is extracted through holes in the screen that are of the appropriate size. And they're extracted by using both positive pressure and negative pressure suction air. The result is a system which feeds in bran, which is traditionally produced, and then it produces two products. One is a combination of alburon and very small bran particles mixed together. And the other is purified wheat bran. Now, what are the benefits of this system? They found that it would increase the yield of their plant because they could more efficiently extract the high alluron flour. They didn't have to use as many breaks. And so they were able to repurpose some of the milling breaks and the sifter surface that they had to be able to increase their flow and become more efficient with the yield. So they got increased milling yield. In this case, they found over a 10-year period that their milling yield increased using this technique by about 1.2%. And what this specifically means is they could blend their high alluron flour that they received from this system back into their existing flour to produce bread flours. And therefore, what they were doing was adding value to that which was recovered from the bran, and instead of selling it for the price of the bran, they were selling it for the price of bran flour. And now would be a good time to talk about the negative aspects of doing this. Because the alluron layer has the largest majority of the minerals that are in the wheat kernel, any extraction that we make of the alluron layer that we add back is likely to increase the ash content. And so let's talk a little bit about ash content. The ash content specification came about because there needed to be some way to define what flour was so that it could be traded commercially to different people, and not everyone was selling a product. And it has proved to be a fairly reliable predictor of how much bran is contained within the flour. Now, it's been this way since the early 20th century. This has been the standard. And everyone has been reluctant to change anything about it. But now there are other techniques. There are color meters, which are accurate. There are falling number testers. There is measurements machines which measure the rate of moisture absorption, all of which are valid indicators of baking performance, and which do not interfere with the extraction of usable flour, although it might be ash. Now, it's true that bran, when it's in a certain shape, a certain size, can interfere with the baking characteristics, because what happens is these fiber particles can burst the bubbles that are developed during the baking process, and they can cause a difference in the characteristics of the baking. But alluron layer particles, if they're extracted in the right shape and size, they don't do this, so they have no adverse effect upon baking. If we look at some representative ash standards in flours, these I took off the internet to be representative, one in North America, one in Europe, and another in South America. These are the standards for the products, ash standards that different products make. And one thing that you'll notice is that in all of them, there is a type of flour that can be used in the making of bread. They're kind of different, but they are all in a range in which the Tres Castillos flour hit. The flour that they made came out at 0.64% ash content, which is higher than a patent flour. But it's all within the range that's acceptable for bread flour. And this means that they were able to go on and maximize, or at least increase, the value of what to them was a byproduct. The financial impact on this, assuming they're the same 1.2%. Now, let's look at that. The 1.2% is representative of that mill. If the mill in question had had a longer flow, it might have the increase might have been smaller than that. If it was a shorter mill, then the increase might well have been larger. But one could expect somewhere between 0.7 probably and as much as 2.5% increase, depending upon what flow you had, in being able to turn what was bran into clear, short, or a straight grade bread flour. And in this case, the annual difference was $317,625, and the return on investment for applying this technology was right at 100% annually. We've talked about increasing the milling yield and shown how that happened. But it's also possible, if that wasn't your goal, there's another thing this does, and that's shorten the mill flow. This slide represents mill flows, break flows, and purification passages that we've encountered. And I want to show you what these would look like if you applied the technology. If you took the one at the top, it would turn into the flow system on the right, and it would have it would turn into between 2 and 4 less roll pairs, and 1 less flour recovery machine, and 3 to 5 less motors. This flow would turn into a simple flow like this, and it would have 2 less roll pairs, 1 less flour recovery machine, 3 less motors. And similarly, in every case, using this technology produced shorter flows that could produce the same flour recovery rate. And what this ends up meaning is that for older mills, the space that you save with the shorter flows can be repurposed for increasing the capacity even further, or it saves in terms of downtime, wear and maintenance, and then spare parts. The final one, and perhaps the most important one, is that it permits companies to make specialty products. This is a specialty product that's already being marketed. If you look at the nutritional values compared to whole wheat flour, it compares favorably with whole wheat flour, and it is made entirely by blending alluron-rich flour that's recovered back with straight grade flour. And so what would be the value? Is it not logical to assume that a product which bakes and tastes like the customer's preferred white bread flour, but has the nutritional value of whole wheat flour, could that not be more valuable? Could we not create higher value products? And when we do that, we are indeed going back to our economic engine, and we're optimizing the efficiency of the engine that flour milling is supposed to be. Now, what's the problem with this? Nobody's doing it except for a couple of people down here in Latin America. Same thing was true in the United States. Nobody in 1984 knew what a minivan was. They had no idea that they existed or could be made, and much less the fact that anybody wanted one. Simultaneously, Chrysler said, this is a good idea. You know that old question, what if? And they, although nobody knew about it or wanted it, they were confident that they could make it, and they were confident that they could convince their public to accept it and depend on it. The result is historic. It's one of the most successful releases. They did it simultaneously in 1984. And they released two models that nobody had any idea even existed. And it became one of the most successful launches in the history of the automotive industry. And it actually changed the fortunes of the Chrysler combination. Isn't it possible that there's something like that waiting for us in the flour milling industry? In order to do it, we simply have to change some things. We have to think of our operation in fiscal rather than in technical terms. We have to embrace change, because without change, there is no progress. Progress implicitly implies that we're going to be comfortable with changing our process. Third, we have to think outside the box. We have to ask, what if? Now, for those of you who think that the purpose of my talk might have been to be a commercial for NutriBricks, I want to assure you that's not true. I do respect the process. I think it works. I know it works because it's been working for 10 years. But it shouldn't be the only process in an industry that can lead us to optimize the economic engine. We may have to think about changing some things in our industry, changing the attitudes we have, convincing the industry to use standards which they're not accepting right now. In short, and in closing, we have to do what the late Robert Kennedy suggested famously, although he himself was borrowing a phrase that was originally coined by George Bernard Shaw. We have to think not of things the way they are and ask why. What we need to do is think of things the way they ought to be and ask why not. Now, I thank you all for your attention, and I don't know if there are time for questions or what's the procedure here? At the end, a discussion at the end. Okay, for that, I'm going to need to put this on.
Hello, my name is Leandro. I've been working for the oilseed processing. Mostly my experience is in soybeans process. And I'm here to introduce the new technologies and roles for flour mill that we call Chronos. That it is a role especially prepared for compression stage in flour mills. Just give me a minute, I'm trying to investigate how it works. Okay. So in Balaguer roles, we believe that for improve the business, the best idea is to use all our knowledge in casting to get the best benefits and advantage to our customer. We are developing roles for many markets, including paints, soybeans, flour mills, chocolate, coffee, beers. And every market has a specific requirement and needs. So we are all the time developing different material for each other. The chrono role I don't like this presentation and I don't like how it is, the order. But this is a development of 6 years. And we are looking for a roll made for only one casting. So I don't know if you have experience of how the rolls are manufactured, but the rolls are centrifugal casting. So we have a die, it is spinning at high speed, and we put the first melting of material. The first melting is the harder, is the high quality material. And then we place another casting inside that it is softer. Instead, the Kronos roll is only one material, right? And the hardness, you can see it is in 350 and 430 Brinells. It's a very wide range, right? Normally, when you measure a roll, you can see a very uniform hardness. But in this case, we're looking to have this inequality all around the roll. One, because we want to have a higher wear resistance. And on the other hand, we have to be self-malleability material. Malleability, I don't know if you know what is that. It is in Portuguese they call chateado, sandblasting. We want to have a higher roughness in the surface to improve the grip of the roll over the material. And also the material is especially prepared to have a high thermal conductivity, so it's easier to reach a uniform temperature all around the roll. This is the advantage. I'm going back to this one. So the roll is a foundation, a casting made of two kinds of material. The perlectic matrix, and in the white is the carbide. This is that deliver the hardness to the roll. And you can see, this is wrong. This is the wrong number. This is 400 and this is 300. The hardness is equal even if your diameter is reducing. And this is because we want the roughness get naturally in the roll. This is the key 01 is our standard roll for compression stage. In the same kind of machining of the roll, you can see the roughness is higher. This is because, again, the Kronos is softer, the black area are the softer, and the white area are the harder in order to improve the wear resistance. So, in order to test the roll, we go to a friendly company, very close to our company. We made the next test. We place in two mills, passage C1 and C2. I'm very sure you know this one better than me. We place the roll K01, that it is all standard. You can see that this roll is higher, the hardness, and another pair of roll of mills with 350, 430 of Kronos roll. And at the beginning we say, okay, make a run and take the Kronos and the K01 at the same power consumption. And you can see that extracted flour is improved around 7%, sorry. Also in the C2 stage, you can see there is a notable increase of the extracted flour mill, right? So then we asked to the people to, okay, try to adjust the key 01 mills to try to get the same flour, and you can see that the power consumption in these mills increased significantly. Question about here? It's okay? So the conclusion of this testing is that the kernel demonstrates to have a lower consumption rate. The extraction of the flour increase, and especially the temperature of the roll decrease. The chronos work at lower temperature. You can see here the temperature on the roll. The chronos is 4 degrees Celsius lower, and in situ is 5 degrees Celsius lower. That I have understand that this is very good for flour mills, right? You don't have to believe me. Budeli, this is our higher customer in China. They sent a special letter stating that they are very happy with this product. They are consuming the Kronos roll and Key 12, that is very hard roll. And also, we get in contact of Nissin, that they are a company from Japan. We asked them, okay, you are a very good customer for Kronos roll. What is so interesting for you? And they say, okay, we're trying to get the flour at 90 micras, right? And normally we need to sandblast the roll each 2-3 months. But with the Kronos roll, they only need, they had to send to sandblasting every 2 years. So this is a very good saving for maintaining staff. And also they measure the ashes, and you can see that in the Kronos roll, it is quite lower that the flour mill get it for the Key 01 or standard roll. Again, I know that ashes, you want to get lower, right? You explained recently, but this is not my area of knowledge. So summarizing the advantage of this kind of roll, we can increase the extraction rate. The roll, we say that it is auto-sandblasted. We have a very good improvement in energy and consumed power of my motors. We have a reduction in temperature, and we have an optimum start damage on this flour. So this is all. I don't know if you have any questions or we have time.
Thank you, Roger. It's good to be here in front of everyone. Thank you all for coming, and I hope to be able to explain a bit about moisture control and why we do it, where we do it, and what you can benefit from it. Okay, so where's the next button? Big green one like that. Thank you. So, as we all know, in natural products, moisture varies continuously due to the growing conditions, the harvesting conditions and storage, and also any subsequent processes before and after the point that we're looking at. That moisture is critical for processing in a number of different locations, for example, in the roller mills. Obviously, it's important to get the correct moisture, to get the correct ground material, the grist, out. In other areas, for example, in drying, it's important to have the knowledge of the moisture to be able to control the dryer to an optimum values and to improve the plant efficiencies. So by adding repeatable moisture control, what do we get? One of the things is we get higher yields because we can target closer to the legal or the allowed limits. We can get higher quality, so where you're grinding and creating other materials, you get the correct quality of materials out of the processes, and you can get higher profitability from that. Obviously, the higher yields from the same raw material give you better profit, which leads back to our earlier speakers' comments about driving using costs. Also, we look at reducing waste because we're doing less incorrect processing. We can reduce energy consumption in mills and in dryers especially. And in the follow-on from that is to reduce the carbon footprint of a process, which is obviously important in the current climate. So where can we actually measure the moisture? So there's a number of different places around the plant, and so I'm going to run through a few of them. Obviously, the main thing is getting a good material flow to measure in. So the first area is in the delivery from the farms and the suppliers, so that transfer off of the trucks in through, potentially through dryers, depending on where you are and the processes. Then into storage and subsequent transfers from storage back out again for processing. In conditioning steps, obviously you want to condition, you add water to get the materials up to a specific moisture value. So knowing the start of that is important to get the right addition of water into that conditioner. And then also after that, you can then measure to show how much moisture has been added so that you have a proof point. That then leads on to the milling. Obviously, measuring in the conditioning helps you to get the best performance from the mills. And also you can measure directly on the inlet to the mill. And then in final product, so either in storage to stop spoilage or into bagging areas as a quality control check as well. So these are all different areas that we look to measure moisture. So different ways of measuring moisture. So currently, a lot of people will know of offline measurements where you can take a sample of material from the product flow, put it either into a handheld device, or you can take it to the lab to do a test. That then gives you the moisture, and sometimes other indicators as well, for example, fat and protein content. Then on the other side of that, we have online measurement. So we can take a continuous measurement of the material in the flow. So it's an inline measurement which is being taken a number of times every minute or second. And there's a few different ways to take this measurement, including capacitance, NIR systems, analog microwave, nuclear, and digital microwave. Why do we want to measure online? So, as we said before, the moisture in the material flow is continuing constantly. Is varying constantly, sorry. And having a full knowledge of the material moisture allows you to very quickly correct for any changes in that. It also gives you an accurate representation of the whole of the moisture in the material in the whole flow, rather than just taking small samples. To give an example of this, the amount of sampling error you get from taking offline samples, if we were to take a sample at these 3 points from a continuing process, you can see quite quickly that that would give you a value which is actually incorrect for the average moisture in that material flow. So whereas it should be around this sort of 23% value, it was showing it at about 24. 25. So by taking a continuous measurement, we can then reduce the amount of error in that. So measuring moisture online, we have a few different technologies we can look at. The NIR systems are very, very good. They're very they're accurate, but they give you also a number of different parameters like fat content and protein content. They do have a few drawbacks. They tend to have quite a high maintenance cost. They do need regular maintenance of the lenses and the light sources, and they can need fairly regular recalibration and checks. So they're also affected by temperature changes, by different dusts in materials, and by colour changes. And it's only really a measurement of the surface of the material. If we then start looking at RF-based techniques, where we're using radio frequencies to measure and react with the water in the material, we then look at resistive capacitance and older analog technologies. So these have got lower maintenance costs, but are still affected by temperature changes and also any salts and other impurities and other materials in the material itself. They also tend to have a non-linear relationship with the moisture, which means that they're a bit more difficult to calibrate and to work with. Then there's nuclear, which isn't actually used very often in food and flour processing. That tends to be very high initial cost and very high maintenance cost. It has a very good measurement, but it only tends to be for large quantities, so complete silos, so not very useful for actual processes. Then we have Hydronix, the digital moisture measurement technique, which has a very low maintenance. It tends to be a single calibration, and then you can run for many, many years with the same material. It's for measurement in flowing materials, though, so we need to have a good flow of materials to measure in to get the best measurement. So what can you benefit by adding moisture control to your processes? So one of the things we looked at was what happens when we're measuring in the inlet and outlet of a dryer. So if you can prevent under or over drying, obviously you get a better performance from your dryer. You're getting better material out, which then gives you less spoilage in in storage silos. And it also allows you to automatically adjust the input to the dryer to get the correct energy going in for the moisture that you need to extract. So we looked at the reduction of the moisture. So as a typical dryer, reducing the moisture from 20% as an input value to around 14%, which was the required the required target. So if you then have a moisture accuracy of 1%, which you can get with regular sampling from a material flow, you would have to target a 13% moisture to guarantee that you will be under that 14% maximum. This means that you're removing 7% moisture. So we can calculate that the energy required to remove that moisture is around 46 kilowatt hours for every ton that you're drying. If we're then looking at improving that accuracy to 0.5%, which is what we would normally have as a guarantee for the moisture sensors, we can then look at only reducing the moisture by 6.5%. So you can see that the energy required drops to 42.6 kilowatt hours for every ton you're processing. So this means that you're reducing your energy input by 7%, which can be quite a lot of money. So if we're looking at a 16-ton batch, just as an example, obviously you get the extra yield so you're getting 80 kilograms of extra weight of final product. you are lowering your energy cost. So in the UK, we've calculated that it would be £15 for every batch. So every 16-ton batch would be a £15 saving in energy. And it would also reduce the carbon emissions, so the equivalent emissions from the energy production, again, in the UK, would have been a reduction of 10 kilograms of CO2 equivalent per batch. So what do you need to look for when you're looking for sensors to measure in processes? They're very important to be able to connect them, because unless you can actually connect your sensors to your plant and to record data and to use that to then control your process, then you've not got much of a hope to know what's going on. So we look at connecting the plant using a network of sensors, which can then connect to a display equipment. We have some for our systems called the HydroHub and HydroView. That can then either directly connect to a PLC control system, or it can connect using the interfaces. That can then be used as a feedback or feed-forward control to give a closed-loop control system. Going out from there, we then put these onto the main network, so generally on the process network in the plant, and that then can be used for Wi-Fi, to connect different systems, to monitor, to calibrate, to gather data from the sensors, which can then be used to then develop AI control systems and other systems for feedback and automatically adjusting for the calibration changes. And then finally, there's the option to then use database and data storage to either feed into MIS systems for monitoring moistures, which can use to adjust weight offsets. So when you're taking material from bins and silos, you can adjust the weights for the moisture in the material, and also ERP systems. So just to draw some conclusions, why do we want to measure moisture? So it's to give a feedback control system to allow you to automatically react to changes in the moisture. This allows you to get benefits in cost reduction, energy reduction, and environmental impact. Where can we measure the moisture? There's a number of different locations around the plant. So on raw material intakes, storage, transfers, drying processes, conditioning, and then final bagging. And how to measure moisture. So you've got the options of doing offline, but we would always recommend doing online methods to make sure you can react quickly to changes in the moisture as it is varying continually in the process. And then finally, that connectivity, being able to use the sensor in your processes, to connect them to your PLC systems, to allow you to adjust to that raw material change in real time, and then use that with Industry 4.0 type techniques. You can then do automated control and even adjustments to process changes using those. So thank you very much, and I hope that's been okay. And if you need any more information or would like to come and talk to us, apart from the questions at the end, please come and find us. We're very close to the VIP pavilion down on in the exhibition.
But as I said in my original introduction, as the moderator, my name is Roger Gilbert. I'm a publisher of the Milling and Grain magazine. I was co-founder of the International Feed Industry Federation, and I'm also the co-founder of the Milling Hall of Fame for the flour milling industry. So without going into any more of that detail, I'd like to address the topic today, which is trends in the global flour milling industry. Now I'm having problems. Is that changing? Oh, there we go. Okay. That's a copy of our most recent magazine. It's at the back. It's in 7 languages. Not here, but you can read it online in 7 different languages. But the future is unpredictable. And what I'm showing is the view from here. And what I mean by that is this picture was taken in 1990. It's by Voyager 1. It is something like 6.5 billion miles from Earth, and that little white dot is where we all live. In 1990, the world population was about 6.5 billion people. Today, it is about 8.2 billion people, and is expected to top out, as it were, the steady climb and growth numbers of human beings on the planet is likely to peak in 2050 at just under 10 billion people, and by the end of the century, hopefully not exceed much more than 10 billion people, 10 or 11 billion people. So that's the forward projection, but there we are, that little dot up there. Okay, so feeding 9.5 billion people by 2050 is going to be our challenge. And my presentation is looking at trends. Where is our industry headed over the next little while, and why? But I've referred to the Crop Prospect and Food Situation Report from the FAO for some of the slides or data I'm about to share. Wheat is a staple foodstuff, and the top 6 foods globally by share and region is expressed in this slide. Okay, up here we have rice, wheat, maize, potatoes, cassava, and other staples. So you can see that wheat is going to remain a principal food for us for a long time to come. While over here, we have a breakdown by rice, blue, wheat, maize and green, potatoes in reddish colour, and cassava. And you can see Asia is predominantly a rice area, rice consuming area. In Africa, that changes somewhat. Maize is most important. In Europe, we're back to wheat. The same in North America, and South America, there's a balance there. But where is wheat coming from? And this is, I think, our Achilles heel. Wheat is basically produced by 7 countries and is traded globally, and has been for a long time. Nothing wrong with that, but having all your eggs in 7 baskets might be a bit risky as our population and trade flows change over the years. And I'm not referring to tariffs, but politics do come in to international trade, and food is in that trade. So looking here along the bottom, 5 countries, oops, excuse me, let me go back. 5 countries that produce the most wheat is China, 137, India at 107, Russia, 104, these are millions of tons, United States just under 45, and Australia at 36. And you can see the density of these 7 countries' wheat production by this table across the bottom, running from under 40 million tons all the way through to the heavily densely wheat populated countries of 140 million tons in the darker colour. Okay, who are the leading wheat producers worldwide? And I've just listed them there. It's another way of looking at the data I've just explained. But not all wheat, as we learnt this morning, turns up in flour. And this is a slide just to show us or remind us of the total wheat production in millions of tons, but also the extraction rates that we're seeing from wheat to food, wheat to feed, and the flour that we can extract from wheat for food. So wheat is playing a very, very important role in several sectors of food production. And here, this is just a slide to look at what makes up the daily diet. World, United States, these are over 30 years, Brazil, China, and India. And you can see that oils and sweeteners is by far the substantial food product. Grains are in there, I'm sorry, that yellow is in 2 shades, and you can see it changing along here, and fruit and vegetables and animal proteins. Just to try to put wheat in the context, or grains in the context of what we're consuming by region, but globally. I also like the figure of per capita consumption. And while you're looking at this slide, I'd like to say in the feed industry, I've done a calculation, a metrics of population versus compound feed produced, and come up with a per capita figure. And I think I can say with some degree of confidence what is the critical level of compound feed per head of population and food security. Every country producing over 135 kg of formulated compound feed per head of population does not face a food insecurity problem. Those below, they do. Anyway, what does all this mean? And what I've done with my slides, which I'll try to switch forward and backwards, is I've tried to translate them into Brazilian Portuguese from the English slide. So I'll refer to the English slide, but I'll flick over to the Portuguese one if you'd like to read them. So, what does this all mean? Staple foods demand will surge. We will see more demand for our staples. Risks include climate change, resource limits, and structural issues in agriculture may hinder our ability to meet that demand. And innovations are pivotal, which we've heard this morning. Smarter farming methods, intensified production, etc. And I think that what we're hearing about and what this conference is about, maximising flour production, is all about innovation, encouraging innovation, adopting innovation, so we're able to reduce our carbon footprint along with other things. So, my paper is about the trends in global flour production, and I just have 4. The first one is health-driven product innovation, and I'm talking about whole grains, fortification, alternative grains, and functional flours. And hopefully you can read a little bit of that about my first trend. The second trend is sustainability in grain sourcing and milling operations. And sustainable sourcing is partnerships with farmers using regenerative agricultural methods to support biodiversity and soil health. I think this is a critical area that we support those who are producing the wheat or the grains for us to mill. Also local supply. It's quite important that we source a lot of our raw materials locally, because one day we may have to become more dependent on those supplies. And energy efficiency, adopting variable frequency drives is just one example of where we can recover or reduce our energy usage. So my trend 2 is all about sustainability in grain sourcing and milling operations. And I think without taking these steps, we will be locked in the past and unable to respond to the demands that are coming our way. Okay, trend 3, reducing environmental impact. We've all heard about the importance of reducing waste. through byproducts such as bran and germ are increasingly utilised in animal feed, and we've just heard away this morning how we can get that nutrition into the human diet. Water management, we all know the challenges we face in some parts of the world with diminishing water supplies and how more efficient use of water management we have to take on board, and lowering our carbon footprint. This is an area where I would say carbon footprint, if we don't know our own carbon footprint, we can't make the necessary decisions going forward to reduce our impact on the environment. I think it's cognizant of every flour miller, every feed miller, every flour miller to actually know their own carbon footprint. Scope 1, Scope 2, Scope 3. It's not rocket science. It's a matter of recording the data and analysing it to see where we can make savings. Okay, and my fourth trend is digitalisation and transparency, traceability. Up here we have digital transformation is taking place, and we've got to adopt that as soon as we can. Blockchain and other traceability technologies allow mills to verify grain and of origin, production methods, and quality parameters. We've got real-time processing monitoring improvements, and we've got digitalisation also allows the industry to upgrade and streamline its warehousing and distribution systems. So, those are the broad trends that I can identify as a novice really in the industry, as an outside observer. But there are other trends that we shouldn't overlook. And market consolidation and competition. There's no, up here we say no virgin flour markets. That means there's no flour markets out there that we can easily take advantage of. Consolidation is ongoing in our industry, and we have a point of that in the UK, currently in the UK, where two currently highly respected and regarded flour millers are already considering merging. Smart milling. We've heard a little bit about millers that are under pressure to reduce energy usage and improve cost control. And we refer to that as smart milling. I think every step we make to reduce our impact on the environment by reducing energy, by improving our waste, minimising our waste, etc., is profitable for us to do. We're not going to do anything that's not profitable. And I think becoming more environmentally engaged is an opportunity to improve our profitability. The odd question is, who pays for all the environment, this environmental protection? Nobody pays for it. We just have to do it. And the more we do, the more margin, or the less our costs are, and the more opportunity to improve our margins. So I don't think we should look at making environmental decisions as a negative. I think we've got to look at improving our carbon footprint, looking at sustainability positively in the way that our business must go forward. And once again, I refer back to our keynote presentation this morning. Okay, AI, Internet of Things, and automation to optimise milling efficiency and traceability and reduce downtime. AI and data tools are key to optimising yield, consistency and sourcing. Modern flour mills are adapting real-time monitoring and predictive maintenance. We have high efficiency roller mills, as we heard just now. Stone milling is also producing better quality and better energy savings where stone milling is still taking place. However, I must add that the adoption of many of these aspects is slow and is challenged by cultural inertia. Okay. Changing consumer trends. I think this is the last one about these points to note. Mature markets are now demanding healthier, sustainable and traceable flour. Specialised, small-scale, high-value production is gaining importance. We can see that almost everywhere. In developing markets, wheat consumption is rising fast due to dietary convergence, urbanisation and industrialisation, and the growth in ancient grains, pulses, flours and functional blends are gaining. So, what are the action points that we should take notice of? These are areas of concern, may not impact our production processes directly, but we need to address them as well. Reducing our individual carbon footprints, I've mentioned that already, explaining to consumers the importance of our particular staple foodstuff as the foundation of society and for society's health. Working together as a global industry to ensure all people born on this planet have access to staple foodstuffs. I think that's almost a human right. Being prepared to work with a variety of grains besides wheat in order to best serve those in geographic locations that can produce local grains more efficiently and productively. Okay, my final thoughts is what's missing? What might we have overlooked? And I think it's data. There are data gaps in our industry. Unlike other industrial centres with centralised reporting, the flour milling industry spans massive industrial plants, regional facilities and small artisan or informal mills. Most regions don't report aggregated capacity, only production or individual company figures. We lack global coverage and uniform metrics. I think there's also an overcapacity in our industry. In China, I know it's by about 2 million tonnes, but elsewhere, overcapacity is a problem within our industry. Okay, now I'd just like to run through these quite quickly. I won't go into the notes here, but what are these countries producing in the way of wheat on an annual basis and daily milling volumes? So you can see here the US produces 88,000 tonnes a day of flour. We have heard that in China, one company is processing 83,000 tonnes a day of wheat. There's China, I mean huge production. Europe, Latin America, Africa, Asia, ex-China, Canada, and I put the UK in there just for reference. Who are the biggest flour mills? In the United States, Ardent, ADM, Graincraft, Bay State, Miller Milling, General Mills, North Dakota Mills, etc. In Canada, we have Ardent again, ADM again, etc. So these are names you may recognise, but these are big operations. Latin America, Bunge, Molinos, Alicorp, Gruma, Molinos, etc. And of course, you will know these, and I've just identified the countries where their production is most significant. United Kingdom, just for reference, Allied Mills, Whitworth Brothers, Cars. Whitworth Brothers has got the Beulah's most modern flour mill. This is the low build 3-story flour mill with everything's integrated, an amazing facility, etc. European Union, Goodman Mills, Grand Williams, etc. And Africa, not overlooking Africa. Asia ex-China. But this data is random. It's not centralized anywhere. We don't know. We think there's about 12,000 mills on the planet, but we don't centralize either capacity or production or the full number of mills anywhere. China itself, we heard of Woodley. Wilmar is a very close contender. COFCO, which is a government-supported flour milling sector. These companies are huge. And I'd like to finish just with a short little statement. Humanity is just a speck of flour in the universe, and let's work together to preserve it. Obrigado.
Bom dia, obrigado. Roger e Roges. Estão muito parecidos os nomes aí. Obrigado. Primeiramente.
Okay, first of all, I'd like to tell you it's a pleasure to be here with such a select group, talking to a different kind of audience when compared to what we are used to doing. And the moment this was proposed to us, they asked us to talk about wheat milling and the wheat chain. And as this is an international road show, I thought that the opportunity would be to show you not just the milling and processes which were shown here, but show you the many opportunities that you have inside Brazil in terms of production and so on and so forth. So opportunities which I believe the whole world looks at Brazil as a country that has a lot to contribute with the food security and the data that was presented here. In 2050, we will have to feed many more people than we are doing nowadays. So basically, when we presented that, we did a fluxogram here of a mill, a wheat mill, and this was also shown. Everyone knows the different phases of a mill. We have the processes for milling that go through a set of equipment which are organized in the industry, a process that you all know. And here we have, let's say, the star, right, which is the wheat kernel where all particles are extracted from. And just to keep a closer look at this image, here in Brazil, we produce wheat basically in two states, which are Paraná and Rio Grande do Sul, both of them at the south, a little bit in the center-west where we have a lot of land. And these lands, during the winter, they could use that land to produce wheat. And our big challenge, I believe, as a producer, as an industry as well, is the varieties and the different ways in which the wheat reaches the industry. Just for you to have an idea, we have a continental state where we have many microclimates. And so during the harvest, according to the variations that we have, there are many factors that change the characteristics of this grain. And our industry one of the biggest complaints is that we cannot have, let's say, a standardized type of wheat for us to do constant milling. So this is a real challenge and a big opportunity for the industrial sector to have equipments that can fit the different harvests that we have, so that daily or momentarily, let's say, we can improve the milling processes, mainly here in Brazil. Because as we have different kinds of kernel and the quality being diverse, because it is produced in different kinds of states, for example, the south of Brazil, the Midwest of Brazil, which has a drier climate when compared to the south of Brazil. So this wheat has different characteristics in the industry, and I believe that the sampling system, moisturing system, quality systems, all these factors that the industry has present an opportunity for better processes to be developed. And perhaps we will go through a disruptive phase in the wheat industry. This industry that is a centenarian, secular institution. So with this system, we hope that we can extract more from the kernel, or perhaps our milling system in Brazil can become more efficient, being able to extract much more than 1-2% in terms of profitability from our processes in milling, so that we can extract better quality flour, better quality bran as well, because here in Brazil the flours have specific destinations as well. We have type 1 for bread, flours which are there for biscuits, and they have different characteristics. So I believe the role of the industry is fundamental in optimizing processes, helping these mills to have more profitability and also more yield. Here, we are in a land of opportunities in Brazil. In the slides that have been shown to us, the wheat is not even the wheat in Brazil is not in the world data that was presented here. We produce around 700 million tons of wheat, and we consume 12 million tons. We use practically 16 to 17% of our national territory to produce grains. So we have an enormous amount of land. We don't have to deforest any area, go on to environmental reserves to produce more. We already have the land, because wheat here in Brazil is a product which it comes from the second harvest. So in Rio Grande do Sul, which is in the south of Brazil, we plant 30% of the available area for soy. We could produce that. We could increase that production to 60% for Paraná, traditional states, and in the Midwest, that it could be planted more because of the dry weather that they have there. But we have national institutions which are developing seeds which are tolerant to that kind of climate, so that they can produce better quality wheat. It might be a coincidence, but nowadays the areas where you produce the most wheat by hectare are in the Midwest of Brazil, near Brasília, which is our capital, in the city of Cristalina, Goiás. It's a state that is not a wheat producer, but with the technology that they have been developing there, they managed to produce more wheat. So what comes to my mind linking all that? These incredible lectures, linking the lectures that we have heard. We are in a country that has many opportunities for milling, for the industry that produces equipment as well, so that we can develop our industry here in Brazil. And I see that within all these functions that we have, A lot has been said about preservation, carbon footprint rescue. We have tests in Rio Grande do Sul that where we plant wheat as a second harvest, it generates neutral carbon, zero carbon. So we don't have environmental problems with wheat here in Brazil. So planting wheat is a solution, environmental solution for the emission of carbon dioxide or greenhouse gas. So, what is missing? An internal work inside Brazil to be able to regulate, bring the credit system to the rural producer who do not really have enough to produce that. Also, the rural insurance is important too because of the climate variation. Many harvests sometimes are lost because sometimes there is too much rain and sometimes there's a lack of rain. So the producer, they are really having trouble to invest even more. So within all this context that I have shown to you, as I believe this is an opportunity exhibition and road show, I would like Roger and in your magazine, Roger, please, to show the world that in Brazil we have a lot of potential. We are one of the biggest producer of food and exporter as well. But wheat, no, we are really below what we could do. So I believe that with a set of ideas and actions, we can improve that data and we can produce more food in a safe way, in an ecologically correct way, and we can take opportunities to the industry, to the producer, to the Brazilian estate as well, improving our GDP, and this final result certainly is food of better quality with a more favorable economic condition to our consumer. We also have to publicize correctly the uses for flour. We have news here in Brazil that there is a negative marketing about gluten products here. So we don't believe that it should be conducted that way. We hope this can improve. As an association of the cereal companies of Brazil, we are counting on more than 120 associated members, companies all over Brazil, more than 1,000 points for receiving cereals, so we can help build this chain. We have milling companies which are our associates there, and we believe that with all that, we will be able to contribute to the chain, show the opportunity in this international event, and with an audience who is devoted to this industry, not to the production chain which we are usually used to talking to. But once again, I see that the opportunity here is gigantic, the opportunity of improvement. I think we can improve our meals so that we can understand that wheat comes from different places with different climates and has different characteristics, so that we can improve the extraction of the wheat kernel. Because, you see, the wheat kernel shows us what it can give us. And also, the market needs to see the possibility that we can transform Brazil from an importer of wheat to an exporter. We export the exceedant that we have in terms of harvest, but we are still importing sometimes. Brazil is so big, continental-sized country. So in the north of Brazil, it is better for you to bring wheat from other countries, such as the US, Canada, and Argentina, than to bring it from the south of Brazil, which would be an internal kind of transportation. We have problems with tax and logistics as well, but, however, I see more the opportunity than the hindrance. The opportunity to transform Brazil into a country that can produce safely, a country that is ecologically correct. We have data to show that our wheat actually captures carbon, so it doesn't leave any positive carbon. It's the opposite. With the second harvest, we have negative carbon. So, and wheat can then capture carbon for the second harvest and can contribute ecologically, environmentally to the world. So I believe that as an institution that has many points for receiving companies, addressing companies, and milling companies, which are inserted in our associate record, we can definitely contribute and become a reference source for the milling market in Brazil. We have a stand here in the show. We can welcome you anytime to exchange information, to contribute to the market, and our doors are open, okay? Our cereal sector is open so that the wheat milling industry can come and talk to us, okay? And ask any questions which are necessary so that we can, because we understand that Brazil is like a big warehouse and a great opportunity for business for everyone. So basically, this is it. I would like to thank you very much once again for the opportunity that was given to ACEBRA in this panel. I'd like to thank for the opportunity of talking to such a select audience that can communicate not just here in Brazil, but outside Brazil, internationally, can take this message internationally. And I hope that you can see in the Brazilian wheat milling system an opportunity for business so that we can evolve together and transform this productive matrix in Brazil, which is basically soy and corn, take it to the wheat level as well so that all the sector can grow together. And I hope that it results in a richer kind of food, more ecologically correct for our population. Thank you very much. I am available for questions during the panel or after the panel, anywhere. I invite you once again to come and visit us after that. Thank you.
Is there anybody with a comment? I think we have an opportunity here. We've got one over here. Sorry, the light's in my eyes. Can you introduce yourself first?
He has just mentioned he's a director from ACEBRA. So watching the technologies that were presented here in the panel, I really see that Brazil lacks these pieces of information about innovations, and due to the problems that Brazil has, as the President Roges has mentioned, the diversity of grains and the way they are sold and commercialized, the difficulty of traceability, of classifying the grain and the destination of the grain according to its use, let's say, the use of the flour that's going to be made of this grain. So I see the producer, the industries and mills very far-fetched from what's happening in the world when you consider these technological updates that can solve this problem that we have of being far-fetched. If our wheat varies a lot due to climate conditions, and if its destination is very diverse as well, technology can bring some solutions in terms of standardization, traceability. This is what I could see. So I ask our president here, how can we take this information, all this information, to the companies? How can we motivate this kind of publicizing, let's say? Once I think there is a lot of mis and disinformation in the industry regarding these new technologies. Excellent question. Excellent question, Roberto. I believe that the best way for us to take this request, let's say, and this information to the market is taking advantage of opportunities like this one that we are having here, an international roadshow exhibition. So I see that with technology help, external technology help, that can help us improve our systems and reduce our costs, we have the main asset, which is the land, the availability of the soil, the availability of water, light, which is not easily found anywhere in the world. So Brazil is a land of opportunities. I think differently from other states and other countries where you have 4 or 5 months where they don't produce anything due to the climate. Here, it's the opposite. We have sometimes 4 harvests during a year. So what is missing? We have to do the homework here, which is to adequate our seed, our system, our economic system, the access to credit, for the producer to have access to credit, our tax system, and this information has to reach every corner of the country. So we, through panels like this and other events where we can participate, we have to communicate internally so that we can grow and be self-sustainable. First of all, we have to become independent from the import. We are importing 5 million tons and using the lands which are available. We can become less independent, we can produce and perhaps reach 30, 40 million tons in terms of numbers. For a country that produces more than 300 million tons in grains, to produce only 7.5 of wheat, well, I think the opportunity here is very big. So it's an excellent question. I think as an institution we have to try to find ways of taking this information to the market, consumer market, and to all the chain as well, so that we can grow and evolve together in a self-sustainable production.
Thank you very much. Thank you for that comment as well. My follow-up question would be on that topic is how engaged are you from a cereal point of view, from a wheat point of view, with the international market? I mean, domestically, you have your organisation, but is the cereal production side engaged internationally? Is there some standardisation or some understanding of what other countries are doing in your sector?
So in a way, yes. So when it comes to wheat specifically, we are only able to export when you have a surplus of it. An example is the state of Rio Grande do Sul. We are able in the past 3 years to have a really strong movement with the second harvest, which wasn't being done before in our state. And we had a production that jumped from 500 to 5 million. We basically doubled the production in 3 years. So the cereal, the surplus of cereal, because of reasons of storing or lack of storing, or for logistical reasons, for us was actually way more economical and fast to connect with the port and then export it. So our wheat then went to several other countries in the world, and it was really well accepted. It fitted very well the standards and international standards. And because of the characteristics, we didn't stop in exporting wheat, even though we are importers. The external market also came to Brazil looking for wheat here, and we don't have that much availability to support everyone. So by answering your question, I believe that we are situated in the international system somehow in terms of producer traceability and good practices. We just actually need this extra drive in order to improve and produce more. But our association always aims to give opportunity, and we are precisely working in events like this to also get more opportunities for our associates, for the companies, for the cereal companies, so that together with their producers over there in the field can finally drive forward this production so we can more and more be more active in the international market with our product that is following the same standard, even superior standard, comparing to other countries sometimes.
Excellent, excellent.
Amazing, excellent.
Any other comment out there?
Excelente. Algum outro comentário?
Oh, yes. In fact, I was going to come to you, Dr.
Eu ia
Bond.
até chegar em você, Dr. Bond. Sim, eu queria comentar, porque se eu entendi a pergunta que você fez, estava falando da questão do Brasil estar atrás, não é mesmo, de alguns países em termos da consistência do que tem sido produzido. A solução para isso, eu acredito que envolve um pouco de tudo que foi discutido hoje, mas também envolve os processos tecnológicos dos seus fornecedores. Porque eu acredito que quase tudo em relação a grãos pode ser conduzida pelos fornecedores, uma vez que eles já sabem o processo, sabem o que vai acontecer. Porque muitas vezes, em várias indústrias, a produção de grãos ela é olhada de maneira diferente, de maneira separada do processamento dos grãos. Então, o que acontece é que você usa os grãos e você planta os grãos, mas aí você pede para um outro setor fazer a moagem disso. E aí, por conta disso, você tem alguns problemas nessa comunicação. Então, o meu conselho principal seria para fazer parcerias com os produtores, com os processadores de grãos e começar esse diálogo. Porque você tem uma oportunidade de fazer algo que é muito difícil fazer, onde ao invés de produzir 5 milhões, você está produzindo 50 milhões, aí você sempre fez dessa forma. Então, eu recomendaria isso, minha sugestão, que seria que você considerasse a produção de farinha, que inclui a produção e a cultivação, a parte da agricultura do trigo, para que você tenha isso até o processo de embalagem e transportação, que você use essa visão panorâmica desde o início e envolva todas essas pessoas na pesquisa e no trabalho que você está fazendo, para que cada um possa lidar com problemas específicos também. Por exemplo, se você tiver algum problema com tamanhos inconsistentes do trigo, isso pode levar a um custo no processamento no final. Mas isso pode ser separado, por exemplo, por alguns processos de especificidade, para que cada um possa lidar com áreas diferentes. Então, por isso que eu sugiro uma verticalização maior da indústria.
Roges, is that something that you can relate to,
Roger,
looking at it from the other way, from the actual end flour all the way back to the grower?
Pensando até no produtor? Yes, I agree 100%. I'm really favorable to that convergence. We truly have that challenge here inside Brazil. That is to make that the field can produce what the industry needs, and even more than that, that the consumers want actually to purchase it and buy them. So it is in that way that I believe that we need to communicate better, and we need to learn with other countries and people like yourselves that come from abroad that are huge producers of wheat and organize our chain overall. I also believe their main homework is to organize our chain, produce what the consumers want. In between, we want our industry to be able to adequate better and try to extract from that we wheat the best possible material so that the producer also have the profitability to offer product for the industry. So we need to create this need. And just to add a few things here, our Midwest produced a lot of corn and exported. For 5 years up until now, it started to industrialize and transform the corn into ethanol. So it created and generated opportunity for the industry. The industry was constructed in the Midwest of Brazil and started to produce ethanol on large scale. So Brazil, instead of exporting corn, is now exporting DDG, or it consumes that DDG and also consumes this ethanol, thus reducing the gases emissions with clean fuel. And I believe we can follow somewhat the same path. We could increase the awareness of our producer, because way in the back, Brazil used to be a country that produced only wheat. After the 70s with the soy chain and its advancements changed a little bit, but because of the profitability, the wheat chain was left behind. So we started producing more soy than wheat. Therefore, what you said was excellent, Bond, because we need the farmers and the government and all society understands that wheat is in deficit both in Brazil and around the world, but that is also an opportunity of profitability. So I think your advice is truly valuable so that the chain can step forward together, all of us knowing where we want to get with quality and production, avoiding surpluses.
Thank you. Don't think that one's working.
You just illustrated exactly what I was talking about.
E até para ilustrar um pouquinho do que eu havia mencionado, que você comentou a respeito, por exemplo, da produção do etanol, né, do milho, no desenvolvimento que aconteceu no Brasil. Então, se vocês processassem milho, vamos supor, se estivesse envolvido no processamento do milho, o germe e o farelo do milho não poderia ser fermentado utilizando técnicas comuns de fermentação para gerar o etanol. Portanto, o que acaba acontecendo nesses processamentos é que você moe o milho e aí você faz o processo de fermento com o amido e isso depois você vai produzir o etanol. Agora, se desde o começo você no seu processamento começasse a pensar de maneira diferente, por exemplo, bom, eu vou pegar o farelo, o germe e eu vou tirar antes de ir para o processo de fermentação. Porque se você fizesse isso, automaticamente você já teria um aumento de 20 a 30% na capacidade utilizando a mesma quantidade de milho. Porque você não estaria, por exemplo, tentando fermentar algo que usaria mais espaço mesmo. E também mudaria a qualidade e a característica desse DDG. Por isso, é tão importante que nós não olhássemos para nenhuma indústria apenas de forma separada. Ou seja, aquele que está cultivando não pode estar separado do produtor, que não pode estar separado do consumidor. No momento que nós começamos a falar sobre o processo, o ideal é envolver esses três grupos e aí nós chegamos àquilo que eu havia comentado de otimizar esse motor econômico.
Thank you. Do we have a comment? Anybody want to add something from the
Mais
floor?
alguém quer acrescentar algum comentário ou
I think that's a
perguntar
very
algo?
interesting point,
Eu
how
acho que
we
sem
join
dúvida
the
nenhuma
industry
foi
up.
muito interessante que nós
I've
conversamos aqui
traditionally
sobre
looked at how we
esse
join the
relacionamento
industry
da
across
indústria, como
borders,
que nós
but I think
juntamos
what you're
indústrias
referring
ao redor
to
do
is much more
mundo, e o que
important
foi dito
of
aqui é
growing what
importante
the
também,
industry
por
needs or the
exemplo,
consumer needs.
em pensar no que é
And
necessário
getting
mudar
that
na
right so
indústria.
that the farmer knows
Chegar
what
no
he's
ponto onde o
obligated
fazendeiro
or asked to
e quem está
produce.
cultivando sabe aquilo
Dr.
que
Bond,
se
I
é
have a
esperado
question
do
slightly
produtor.
different.
Agora,
you
Dr. Bond, eu tenho uma
presented
outra
a new
pergunta para você.
process
Você havia
to us this
apresentado
morning that
processo
you think
novo
has the
para
potential
nós, que
to
você acha que tem
revolutionize
potencial de
the flour milling
revolucionar
sector,
o setor de
possibly
moagem de
globally.
farinha, talvez até mesmo
How
a
do you
nível
see that
global.
taking place?
Como que
I mean,
você
it's
vê que
intriguing
isso vai
what you've explained
acontecer?
to
Porque
us
é bem
and
intrigante
why it
aquilo que
should
você
work and
explicou
why
no
it is
início,
working.
por que deveria
But how
funcionar.
do you,
Então, como
like a
que
startup
você,
company, how do you get to the
da mesma
next
forma de uma
stage?
startup, vamos supor, como que você chega no próximo nível? Eu não
Eu
sei se você consegue chegar no próximo nível se você não está disposto exatamente a desafiar um sistema que diz que tudo que é utilizado na indústria de farinha tem que ter um conteúdo de cinzas menos de 0,5%. Sabe, é necessário estar disposto a olhar esse dado, esse valor e pensar, será que isso é de fato relevante? E aí, se você realmente fizer isso e lidar com associações e lidar com grupos maiores, como por exemplo a minha empresa poderia mudar por si só a maneira de trabalhar, mas ela só se tornaria aceitável a nível de padrão se vários produtores se juntassem e falassem que isso também faz sentido para eles. Então eu acho que a gente só chega no próximo nível não só a nível individual dessas empresas, mas a nível de associações, como por exemplo associações internacionais de produtores de farinha, de moinhos, para que haja uma pesquisa colaborativa em outros lugares, como a gente tem pesquisas acontecendo em estados dos Estados Unidos, porque seria
I noticed you had a reference to Codex Alimentarius up there,
várias indústrias.
and maybe this needs to be something that
Verdade, como
should
você
be
mencionou,
addressed as
talvez
well
seja algo que
because that's
necessário ser
the
discutido por
organisation
outras
that controls the
organizações, né?
trade
Até
internationally
porque há
of our
organizações
foodstuffs,
que controlam
and
o
they've got
comércio
to obviously sign up to something like that as
Então é
well.
necessário que essas
And I think that
associações também façam
reinforces
parte
the
dessa
point I'm trying to
conversa. Eu acho
make,
que tem a ver pouquinho
is that
com o
we
que eu
need
estava
to be
falando,
operating
a
more
necessidade de nós
together
precisarmos
globally.
estar
We need to
operando
have
mais
some sort of
colaborativamente
commonality
juntos,
about our
buscar
goals and
pontos em
objectives,
comum,
even though they might be slightly
objetivos em comuns,
culturally different.
apesar de ter
I
uma
think
certa
it's
diferença
important that we
cultural.
understand
Eu
as
acho
an industry
importante
each
nós
other
entendermos
across
como
borders.
indústria uns aos
But
outros,
we've heard some interesting
independente
things here.
dos
Yes,
países.
want to add
Sem
something?
dúvida, ideias muito interessantes. Pois é, e eu queria acrescentar mais uma coisa, já que você me deu esse espaço para falar sobre isso, e eu sei que geralmente quem é mais velho gosta de falar bastante, então eu vou falar um pouquinho mais. Quando nós pensamos em mudança da indústria, é necessário ter bastante cuidado em obter dicas e ideias de pessoas que não estão necessariamente envolvidos no sistema, porque o que é benéfico é para que você nunca se apaixone com a ideia de uma pessoa por si só. A ideia é ouvir as outras pessoas, é ouvir ideias, claro, saber valorizar coisas como honestidade, como certeza, a habilidade que as pessoas possam ter em olhar para a situação de maneiras diferentes, porque no final das contas é para benefício de todos melhorar a maneira como eles já estão trabalhando para dominar o mercado. Isso pensando, claro, nas pessoas que estão envolvidas nos processos. Então, uma das coisas que é necessário fazer é que é necessário você estar junto, mas não só pegando essas informações do que é tecnicamente melhor de pessoas que só querem vender para você.
Neal, you've been sitting there quietly listening to all this. And you actually sell products, a very important piece of equipment across multiple countries. What's your take on how coordinated the industry is and how it's how you see the differences between locations or countries? Can you make a comment around that?
Yeah, I mean, a lot of where
Nós viajamos pelo mundo todo e aí nós tivemos processos semelhantes. O equipamento de produção é praticamente o mesmo, porque você está fazendo a mesma função. Muitas das coisas que procuramos trabalhar na verdade, encontrar parceiros que são confiáveis, que podem te dar uma solução para um problema que você está tendo e que pode ajudá-lo a fazer os sistemas funcionarem. Não é só vender e sair correndo, não é? Não, a ideia é que depois da venda você dê suporte. E também com a tecnologia moderna, nós conseguimos ter mais dados, mais pontos de dados, para que eles possam ser coletados e que a gente possa ver os efeitos das mudanças que foram efetuadas a partir desses dados que foram recolhidos, não é? E aí você pode inserir isso no sistema de blockchain para poder dar a informação para o consumidor também, para que o consumidor possa confiar naquele produtor, né? Por exemplo, informações sobre o meio ambiente, sobre a produção, etc.
Anybody
Muito
else with a
obrigado.
final comment?
Mais alguém tem algum
Do I see a hand up?
comentário final? Vejo uma mão levantada aqui.
Joy? I think, don't know whether that microphone's on, but ask him.
I liked the presentation very much from Hydronix with regards to the moisture in wheat grains. I have been working with that for more than 30 years, controlling moisture in seeds and individual grains. Your equipment, does it have the capacity to measure the moisture of individual wheat kernels that will go into the process? This is a more important piece of information than the sampling that is done by the operator. Does it have the capacity to do that? Então, os sensores são desenhados para dar uma ideia do valor agregado. Então, vai dar uma leitura do volume. Por isso que nós buscamos uma grande quantidade de material. Então, isso vai te dar uma reação online quando houver uma mudança. Então, não só quando você estiver pensando em grãos individuais, você tem que pensar nos grãos que estão em sua frente, à sua frente. Eu conheço a IOM nos Estados Unidos. Está correto? Você ia falar dessa empresa?
You can have
Você não consegue escutar, ok. Ele está correto. O que essas máquinas fazem, eles vão dizer, se você tem uma média de grãos que estão em frente desse sensor, aí você pode ter algo um pouco mais preciso quando você estiver usando uma monitoração online contínua que esteja disponível. E a razão é que você tira os problemas que vêm com o atraso entre analisar a amostra e ter o resultado. Então, você vai te dar uma informação rápida para que você possa reagir rapidamente. Você pode usar muitas coisas online, por exemplo, a cor, a quantidade de sementes, qualquer uma dessas coisas. Você pode de fato medir a ponto de ter as amostragens online que vai te dar um feedback instantâneo. E daí você vai não ter mais esse problema de ter que se preocupar demais com esse grão individual, porque você vai ter uma leitura rápida dos grãos em geral. E tem uma máquina que pode fazer um volume muito rápido, 5 vezes por hora, e pode te dizer qual é a proteína
analysis to sort high protein from low protein. And I'm sure that same technology is, I don't know, but can be used for moisture as well, based on individual grains.
Okay. Útil, mas essa tecnologia
look, I think
we've
had a good chance of a discussion. I would just like to offer our guest speakers an opportunity to make one last comment. But I think we've had a wonderful morning, even though there's few of us remaining. I think that the topics are really important. We will be promoting them. You'll see them online through our platforms. But, I'd just like to thank you for your comments. But right now, can I just ask for one closing comment from each presenter?
Hoje vocês poderiam fazer, então, comentário final? Well, once again, I'd like to thank you for the opportunity I'd like to say that we are here in a field of opportunities, and we, as a cereal sector in Brazil, we've had one more opportunity of showing how much Brazil lacks in terms of information and organization in order to be able to be aligned with all the chain so that we can grow together, so that we can offer better opportunities to Brazilians and to the world market. So I'm really glad to have been here and with all that, and I am sure that we will leave better than when we came in. So we will show all the audience, the national audience, the enormous opportunity that we have for improvement of processes in Brazil and the production of grains as well.
Thank you.
Bem, eu gostaria de agradecer também e dizer que sim, é sobre a jornada de dados que foi mencionado aqui em algumas das apresentações que eu vi essa semana e poder coletar informações para podermos otimizar a eficiência dos processos e dos materiais.
And from the perspective of my presentation,
E
I'd
da
just like to
perspectiva
add
da
that
minha
looking at what
apresentação,
trends are,
olhar para as
identifying the direction it's
tendências,
taking
eu
us,
acho
and
que
actually
está
doing something about it is really
nos
important.
mostrando que
And
temos
I've
que
highlighted
fazer
those that
uma
I
coisa
think
muito
are
importante
important,
a
but I'm
respeito das
sure
tendências.
each
Eu
individual
tenho
has a
certeza
different
que cada
concept of
indivíduo
what the
tem
trend is that's
conceito
most important to them.
sobre
But
qual a
taking
tendência
action
mais
is
importante,
what it's all
mas
about.
agir, é agir que é importante. O que eu diria é que se eu puder ajudar qualquer um de vocês de alguma forma, por favor, entrem em contato comigo. Eu gostaria muito de falar com vocês.
Thank you
Viram,
very
eu
much.
adoro
And
falar.
on behalf of
Muito
all our speakers,
obrigada.
including
Então,
the,
em nome de todos os oradores,
who
participantes
listened
aqui,
here, thank you very much for
aqueles que não
your
puderam mais estar aqui,
contributions,
muito obrigada
and
por suas
look forward to seeing you
contribuições e
possibly
espero
in 2 years'
vê-los,
time
talvez daqui a
at the
2
next one
anos
of our little
novamente
conferences
na
on
próxima
how to maximize
conferência em como
flour production. But
maximizar
thank you very much
a
for attending.
produção de
Thank you
farinha.
to our
Muito
translators
obrigada,
back there.
obrigada aos
A wonderful
tradutores
job.
também.
Thank you for Spanish
trabalho
and for
maravilhoso.
Portuguese and English.
Muito
And
obrigada.
thank you for attending.
Muito obrigada por terem
thank you.
vindo também. Boa tarde.